The presentation that we have for you here, Mr. Todd Gardner is presenting a topic entitled Tricks of the Trade, Small Actions and Simple Tools that Can Make a Big Difference in Marine Fish Culture. Todd Gardner is a professor of marine biology at Suffolk County Community College in Riverhead, New York. His life and his career have both been shaped by his passion for marine life, and he has written numerous scientific and popular articles about his research and experiences collecting, keeping, and culturing marine organisms. I present Mr. Todd Gardner.
Thank you. Good luck. Thanks. Well, thanks for having me. So as you can see, the title changed slightly from what's in the program, but it's the same idea. As was mentioned, I work at a community college. I maintain a small marine science lab, which is basically just my classroom with fish tanks. And I keep these fish tanks for a couple of reasons. One is to keep a nice variety of interesting marine life on hand and expose my students to things they might never see or at least notice that are found right in our local waters. And also to continue one of my biggest passions in life, which is breeding marine fishes. And over the last few years, I've had some really amazing opportunities to work with some of the coolest and rarest fishes out there, many of which are in my lab right now. And so this is really, most of my career has revolved around breeding interesting species of marine fish, culturing them, and trying to convey whatever information I can to the public about techniques. One other thing about me and my family, which you know if you've been to our house or watch us on Facebook, is we're very passionate about food. We love to eat food and cook and bake, and if you've actually been to our house for dinner, and I think a handful of people in this room have been to our house for dinner, then you're also familiar with our favorite cake that we make, which is this. It's called the Norwegian gold cake. It's a family recipe it's been in my family for as long as I can remember. It's a really awesome cake, and you'll see in a minute why I'm going off on this tangent. It actually does relate. Anyway, it's a great cake, and almost invariably when we make it for someone, they ask for the recipe. One of the great things about it, it's fine to put on toppings, whipped cream, strawberries, but it's really a great standalone cake too. You can eat it just by itself, and it's surprisingly good. So, in fact, we made it for our wedding, and Ashley had the good sense to print out in advance a bunch of recipe cards to give people in anticipation of all the people that would ask for recipes. And so we gave them out, and one of my friends in particular came into work a few days later and said, you know, my wife tried to make that cake and it didn't come out right. Did you leave something out of the recipe? I said, no. I looked it over. I said, no, everything's here. Well, something's missing because it's not coming out right. And then a couple of weeks later, yeah, we tried it again, still, it's not coming out right. Then one night they were over for dinner, and she's watching me make the cake, and she's saying, hey, wait a minute, it doesn't say in the recipe that the eggs have to be room temperature. It doesn't say that you need to slather the butter on the pan with a pastry brush, and over, all of these things. And I realized, wow, it kind of does have a lot of little nuances to get this cake to come out of the pan right, and to get the crust nice and crispy, and to get it to the right texture. And I started thinking about how to update the recipe so that someone could make it and it would be foolproof. And I realized it would be 10 pages long if I put in every little nuance of this recipe. And I also realized that a lot of my friends who were very experienced bakers, when I gave them the recipe, they had no problem, because they know that when you have a cake that has this much butter and this many eggs, you need to warm them up before you start. And when you have a pan, it's important to use a pan with a very high surface area. We talk a lot about surface area in my biology class and all of the benefits to having a structure with a high surface area. In this case, the high surface area, the benefit is that you have a lot more surface area of the crispy crust. That's the best part of the cake. But anyway, When you have so much surface area, you need a lot of butter, and it's tricky to get butter into every little crevice. So people that are experienced bakers had no problem with it. People that were just used to following simple recipes had big problems with it, and so they needed a lot of extra help. So when it comes to larval rearing, I feel like there's a lot of parallels. When I always, whenever I raise a new species, I try to get the information out there. I lecture to all of our local clubs, I write articles, I basically give out the recipe for how to culture whatever it is, the species of the month. And often at the end of a lecture, or after having finished an article, I realize, there are some little nuances that I couldn't include. Or someone will come to me and say, hey, I tried doing this and I'm struggling with keeping my algae cultures alive, or growing enough food to feed my larvae, or getting the larvae to live past day 5. And I start asking a line of questions, and I realize that there's a lot of details, a lot of little tiny things that I'm constantly paying attention to that someone who wants to just follow a recipe to raise larvae can't get out of a 1,500-word article, or a 45-minute presentation, or in my case, a 2.5-hour presentation. And so they struggle often to replicate results. And I think a lot of the time it has to do with some of these little nuances that maybe an experienced aquaculturist is familiar with. But if you want to just follow a recipe, you're not going to necessarily get it right. So I started developing this idea, in part inspired by the Norwegian gold cake, also in part inspired by a visit from Richard Ross at the aquarium, at the Long Island Aquarium, where I spent 11 years working. He came to visit, and I noticed him taking notes and writing down some very small details of the things I was saying as we were going around and doing, he was following me through a day of aquaculture at the aquarium. And I noticed some of the small details, and I was saying, why do you need to write that down? And then I realized, yeah, there's a lot of very small details, and that's a detail that would never make it into one of my talks or into one of my articles. So I'm gonna cover as many of these as I can, and some of them are not such small details, as you'll see. Some of them are things that everybody probably knows if you've tried your hand at breeding. Some of them, though, are much more subtle. We're going to move through a few different areas. Some of the areas we'll talk about today: phytoplankton, zooplankton, broodstock, handling eggs, larvae, larval rearing. We'll talk about some other considerations too. In terms of communicating successfully and people taking you seriously, font choice in your presentations is important. The next one actually says font color, but it's in black. But these are things that you need to take into account. So we'll start at the base of the trophic pyramid, phytoplankton. One of the reasons I arranged this as a pyramid, besides that Ashley suggested it, is that I think a lot of people underestimate how much importance to give phytoplankton and how much space to devote to it. When I see someone with a fish breeding room and they have a shelf with 4 little soda bottles of phytoplankton, I say, how can you possibly raise enough phytoplankton to meet your needs in this lab? And if you think about the basic ecological premise of the trophic pyramid, the primary producers always have to be in far, far greater abundance than even the next level up, the next trophic level up, the primary consumers. And the higher up you go, the smaller amount of biomass you have as you move up the trophic pyramid. And I'm not saying you necessarily have to have more space devoted to phytoplankton than all the other stuff in your lab, but probably you're not devoting enough space to growing phytoplankton. But some other points about phytoplankton. One, if you're seriously growing phytoplankton, I mean not just some random thing that bloomed up in some aquarium water and you keep in a jar on the window, your basic green water, but trying to grow specific species of phytoplankton, you really need to use some kind of a sterilizer. Whether it's an autoclaves can be $100,000, or you can find a pretty affordable one. The one we used at the Long Island Aquarium and is still going there, it must be there for 10 years now, was about $1,500, and we've really gotten a lot of mileage out of that machine. And if you don't want to spend $1,500 on an autoclave, you can spend about $300 on a really good pressure cooker that's designed for canning. But if you don't in some way increase the pressure, you're never going to properly sterilize these primary cultures. And if having a sterilizer isn't possible for you, then make friends with someone at a school or a veterinary office or a dental office, someplace where there's an autoclave, and borrow it once a month. But you have to increase the pressure, because if you can't just sterilize the jars, you have to sterilize the media too. Some people will put their flasks into a microwave and get it up to the boiling point and call it good. Well, the problem is that it's only going to get up to the boiling point, even in the microwave, and if you get it above that in the microwave, the water's all going to just boil off. It's going to bubble right out of there. If you just heat it up to the boiling point in a pot, in a double boiler or something, you're going to reach the boiling point and you're going to kill most of the stuff, but it won't really be absolutely sterile. You have to increase the pressure to above atmospheric pressure to raise the water to above the boiling point without it, well, to raise it above 100 degrees Celsius without it boiling over. So, got to do something about the pressure. For the primary cultures only, really. Another thing, you'll see we cover the flasks with a little foam stopper and then put a piece of foil over it. And this way you have the flasks sitting around, usually in a nice covered, clean container, for up to a few weeks before you use your sterile technique and inoculate them. This helps keep dust and spores and things from settling onto those foam stoppers. This was the thing that Richard Ross, that I remember, that stands out in my mind, that he wrote down, shiny side up. I said, we always put the shiny side up when you're about to load them into the sterilizer. And the reason is, you notice aluminum foil has a shiny side and a dull side. And when you get it really, really hot in the autoclave, the shiny side turns dull. And a lot of times you don't have time to sit around and watch the whole cycle and watch the thermometer. So you put the shiny side up and you leave, and you don't want to open the autoclave until at least the next day. You want to let it cool down very slowly to avoid too many minerals precipitating out of your seawater. You come back the next day, open the autoclave, and you can see that the shiny foil has become dull, and you know that it reached critical temperature. They also sell heat-sensitive tape you can put on there that turns color. That's just an extra thing to buy. Or if you have one of the $50,000 autoclaves, it prints out a report for you that tells you what temperature it got and how long. It tells you all the details of the cycle, but if you want to spend $50,000 on an autoclave, fine. Or you can just use shiny side up, the shiny side up rule. Some other rules. As you can see, I never really grow phytoplankton in an ideal setting, in a sterile room. Most really serious aquaculturists have a room that's devoted only to phytoplankton. On the left you see at the Long Island Aquarium, this was right on a major thoroughfare of tour groups coming past, and the back of the shark tank. These things could literally get splashed if a shark flips its tail nearby. Water from the shark tank would splash on those tubes. Currently, this is my phytoplankton culture area in the prep room of my lab, right under a whole big stack of books and other equipment. But I've managed to go for quite a while now without any major contamination problems, and I think some of the tips I'm going to tell you here are part of the reason why. One thing that I've come to really stand by is not only to minimize the number of algae transfers beyond that sterile primary stage, but I only do one transfer beyond. I go from the primary stage to whatever my final stage is, and that's it. Each time you have to open a container, or you have to open two containers and take some algae out of one and put it into another, that's a chance for contaminants to get in, for spores in the room to settle into there. So I only do one transfer beyond, I only go up to the secondary level in phytoplankton culture. This is An idea I got from Andy Rhine at Roger Williams University, instead of trying to use bleach and sodium thiosulfate on those secondary cultures which don't fit into the autoclave, or in many cases your vessel would melt in the autoclave, and even if you had a $50,000 autoclave where you could fit one of these 3-gallon jugs in and use, and these are $250 polycarbonate jugs that are autoclavable. I could put them in, but with that volume of water in them, they would never reach temperature. So they couldn't be sterilized in the autoclave anyway. So he said, oh, well, we just pasteurize our big cultures. The water, they actually have a really fancy pasteurizer where the seawater flows in and flows through and gets heated up to about 150 degrees as it goes through, and then it's heated to a high enough temperature to kill almost everything. It's not absolutely sterile, it's pasteurized like your milk. But I found if I put a 300-watt aquarium heater in there and take the controller off and just let it go for about 3 hours, the water in the container reaches 150 degrees, and as long as I use that algae before it gets too far past peak density, I never get contamination. I've never had one of these get contaminated since I started using this technique. Another common shortcut you see in algae culture is the idea of reblooming. You can't grow, from the time you go from a newly inoculated culture up to ready to harvest, sometimes it can take a week or more. And if you're using algae faster than you're making it, it's tempting to try shortcuts. One common shortcut is you use about 2/3 of your vessel, and then you add clean salt water with nutrients back into it, and you let it should jump back up to that peak density very rapidly. But the problem is now you've got, even if you pasteurize that water you're going to pour in, you've added another big opportunity for contamination to take place. And when I do the rebloom technique, I'd say about 50% of the time the culture crashes before it gets back to peak density. So definitely avoid that. Use CO2. This will get your cultures bloomed up faster because A, there's a lot of photosynthesis going on in there, and the light-independent reactions of photosynthesis require lots of CO2. B, it helps to keep the pH from getting too high as the cultures bloom up. And C, I forget, but maybe there was just only A and B. But the point is, injecting CO2 into the air going into the algae cultures is really great. It helps bloom them up faster, hold them longer, and get them to much higher densities. And you don't need a fancy CO2 injection machine to do this. What I've done is I just have a little bleeder valve coming off of my CO2 tank, and it gets delivered by an airline into a plastic shoebox, and my aerator is sitting inside the plastic shoebox. So the CO2 is just getting mixed in with the air where the aerator's taking it from, and it's getting delivered into these vessels. And ever since I've done that, I'm getting much higher densities. And if you can grow them to higher densities, you don't need to grow as much volume. It actually saves you salt water to grow the phytoplankton at a higher density. And of course, you have to use them or lose them. If your need for phytoplankton drops, then you need to just keep taking it out and throwing it away, or feeding it to your reef tank, or feeding it to your sponges. I don't care. But it's going to start crashing. Once you let it get beyond that peak density, it's going to crash very soon. So it's difficult when your larval tanks vary from week to week, or your zooplankton production varies from week to week. Your need for algae varies. And so when your need drops, if you don't change something about your culturing, then you're going to start having crashes. And that's just from letting them get too old. The best thing to do is just keep that machine well oiled. Keep taking out the same amount of algae all the time and using it somewhere if you're not using it in your larval tanks. Another thing, Culturing algae always involves bleaching something. Usually it's your secondary and tertiary tanks. And just like when I was in school, I used to always forget and wear a white shirt on spaghetti day, and I would get red stains on my shirt. Very often I forget and wear something other than a white t-shirt on the day when I have to bleach my vessels, and I've ruined many, many shirts. So try to remember when it's the day that you have to bleach things in your lab, whatever those things are, to wear a white shirt. Also, you may not want to spring for a microscope, but use a microscope once in a while on your algae cultures. You don't have to use it every day, but a lot of times people will tell me, oh, I've had this nanochloropsis I've been growing for 7 years, and oh, I don't use any sterile technique. It's so hardy. And I know that they don't have nanochloropsis when they tell me that, because it's not that hardy that you can grow it for years on end without using sterile technique. Probably what happened is it got contaminated with chlorella or something else very hardy along the way, and their cultures stay green all the time. And since they never look at the cells, they don't realize that they don't have nanochloropsis. Another thing, though, is that sometimes, especially in those secondary cultures, if you just peek at the cells once in a while and see that there's nothing else in there, it just gives you some good peace of mind. If you are having some crashes here and there, and you look at a sample under the microscope and you see different size and shaped cells swimming around, you know you have a contamination problem. So you don't necessarily need a microscope, but you at least need a friend that has a microscope. On to zooplankton. My number one rule for growing zooplankton is try to use live phytoplankton. Now, a lot of people can get by growing all the fish they want on just rotifers, and you can grow plenty of rotifers on various plankton substitutes, algae paste, dried algae, frozen algae. But if you're trying to grow copepods, and everyone knows that copepods are king when it comes to larval fish culture, then you're really not going to have great success unless you are using live phytoplankton. And a variety really helps a lot. For most copepods, if you're using only one species of phytoplankton, you're not going to have great long-term success and get them to very high densities. Also, use a microscope once in a while. You can practice estimating density, and it's a great idea. Get a really good, fine, focused flashlight, point it into your live food tank, whether it's rotifers or copepods, point it in, look in the beam, and eyeball the density of critters moving around in there, and try to look at their mode. Even if your vision's not that great, in that fine beam of a very bright light, you can see these things. Do that, and then put some under a microscope and count the density. You can get very good in a short amount of time just looking at the beam of light and saying what the density of food organisms is. And then use a microscope once in a while to check for contamination. Sometimes you check and you find something good, some contaminant that you didn't necessarily mean to grow, but might be useful for you down the road. Also, make and use a set of sieves. Buy from Pentair or one of these aquaculture suppliers. Buy a variety of different mesh sizes of nylon or polyester mesh, and make yourself some sieves for sorting out plankton by size as needed. You can also make yourself a little, I don't have a picture of it, but there's a fancy little gadget where you can use a cylinder wrapped in maybe 100 micron mesh with a little airlift, gently putting culture water into a 35 or 40 micron sieve, and this will allow you to collect out copepod nauplii, or very small ciliates or small zooplankters, while leaving the larger ones behind. And this is great if you have a brand new batch of very, very small larvae and you don't want to flood the tank with all different size zooplankton, many of which they're not going to eat. My technique always has been in the past, put a few adult copepods in, let them breed right in the tank, and get the nauplii in there that way, but it's hit or miss. If they don't breed right at the time when your larvae need to eat, then you're going to lose that tank of larvae. So having some ability to size sort, and incidentally, if you don't feel like making one of those nauplius collectors, I think Chad Vossen makes and sells those now from Vossen Aquatics. Of all the copepods, and there's lots of different classes or subclasses of copepods, but the three that are most famous to us in aquaculture are the harpacticoids on the left, the cyclopoids in the middle, and the calanoids. The calanoids are the best ones to target, and luckily for all of us, they're now available commercially from Algagen and from reed mariculture. Calanoids are the best for a couple of reasons. One, they're almost purely herbivorous, which means they're not going to eat each other, they're not going to eat zooplankton, and you can grow more of them with less energy. Also, they're almost exclusively pelagic, whereas the calanoids, the harpacticoids and the cyclopoids both tend to be benthic or semi-benthic, which means they spend time clinging to the walls, clinging to your larvae, clinging to your hands, and they're not out there in the water column for the larvae to eat. So stick with calanoid copepods if you can. Rotifers, we're moving away from rotifers. They have their place. That place is in a room on the other side of your facility from your copepods. Otherwise, you're going to end up with a situation like this. Most of my cultures right now look like this, I'm sorry to say. Mixed copepods and rotifers. They get into everything. They produce tiny eggs that dry out and become airborne and get into other tanks. And if you have them anywhere near your copepods, eventually you're going to have rotifers in your copepods. It's not the end of the world. Don't burn down your lab because your copepods got contaminated with rotifers. You can still grow a lot of great stuff with this mix. But if you want to keep pure copepod cultures, keep your rotifers far away. Artemia, we're moving away from Artemia. Artemia has its place too, though. Its place is in the Great Salt Lake. It's not in your fish room. At least not if you're trying to breed saltwater fish. We still use it. Sometimes it's just irresistible. You can hatch out as many as you need. You can enrich them with whatever you want to try and make them more like copepods, but you don't have the size range that you have with copepods. You don't have the nutritional, the nutritional profile that you have in copepods. And maybe one of the biggest reasons to get away from Artemia is this. All of us here are interested in aquaculture for the number one reason probably is to make our hobby more sustainable, to get away from collecting from the wild where we can, where it makes sense, and raise things in captivity. And what a lot of people don't realize about Artemia, because you hear about things that are called brine shrimp farms and hatcheries and whatever, but those cysts that you buy all get collected from the wild. People don't produce those cysts. It's a commercial fishery. You go out into the Great Salt Lake during the harvest, and it's just like the lobstermen in Maine or the clammers on Long Island. These are fishermen. They're baymen out there that are literally sometimes murder each other over turf, and they're collecting a wild resource. It's strictly regulated because we're taking more of it than the environment can sustain. And if you're buying huge amounts of Artemia cysts, you're contributing to something that's not sustainable in this industry. So try to get away from it. On to broodstock, eggs, and larvae. So obviously, one of the most obvious things, this is not a little nuance, this is something that you obviously know if you're into breeding. Feed your broodstock very well. This is not like our display tanks where we keep things on the brink of starvation so that we keep our nitrates and phosphates low and have a nice clean tank. Broodstock needs a lot of food. It takes a tremendous amount of energy to make good, high-quality eggs and sperm. They need a lot of food. If you want to know what needs to be in the broodstock diet, there's some great papers out there. There's even more papers on what needs to be in larval diets, but you can look at larval requirements. What do we know about larval requirements? Well, they need very high levels of the essential fatty acids, DHA, EPA, arachidonic acid, and with a very high proportion of DHA. You should mimic that in the broodstock diet, because think about where the initial nutrition for any larva comes from. Not from that first copepod they eat, but from the food reserve, the oil droplet or the yolk that's in that egg that comes from the mom. And so if you're not getting that nutritional profile into the broodstock, then they're not going to have that initial nutritional boost that they need just to develop to the point of being able to eat food. So give your broodstock a good diet. We feed very heavily LRS Fertility Frenzy on our broodstock right now, and also Fish Frenzy has a lot of great stuff in it. I'm happy to have helped or contributed to the development of that Fertility Frenzy, mainly by suggesting to Larry that you make something that's geared toward broodstock, and sending him a lot of papers about broodstock nutrition and what it takes to make good eggs. And he really took that to heart and made what I think is the best broodstock diet available. Some other things in there, we see Piscine energetics, mycids. There's a Copepod product there that I get, and I'm going to probably forget when I talk about some vendors that I appreciate in the industry. I might forget this one later, so I'll say it now. There's a company called Gemco in New Jersey that it's a small operation, and they sell things. It's a mail order place, but there's a lot of things that they get that you just can't get anywhere else right now. And this is one of the products I always get from them is this frozen copepod product that it's wild collected frozen copepods in a very high density. And I give that to small-mouthed broodstock, and I use it in grow out also. Some other things in the way of getting good healthy eggs and larvae though. A lot of the fishes, even though they're from the tropics where we don't think of it as being seasonal, they are seasonal spawners. Either there's a wet season and a dry season, or a warm and a cool season. A lot of species spawn on a lunar cycle. They coincide their spawning with the new moon or the full moon. Photoperiod and temperature always play into these kinds of rhythms. And you can manipulate. If you know the spawning season or the spawning structure of your target species, you can manipulate them into spawning when you want, to some extent. You can alter these photoperiods, you can speed up the year, and you can manipulate things into spawning outside of their season. But what I've found is that by whatever means you manipulate them, it seems like, and I don't necessarily have hard data to back this up, but what I have noticed, I noticed this especially with the Leiopropoma, is that when I alter my light cycles to mimic the lunar cycle and to mimic the annual cycle, it concentrates their spawning around those times, around the new moon or the full moon or around their season. And so if you, instead of trying to manipulate them into spawning when they're not supposed to, use your powers of manipulation to reinforce natural cues, then you're going to get them more focused on those times, and I think they're going to produce better eggs. You always want to minimize stress. You don't want kids banging on your tanks. This is something that's impossible to avoid in a public aquarium, and things like sand tiger sharks really don't care about kids banging on. They're not scared of little kids. But if you have your tank in a high traffic area or someplace that's subject to some kind of stress, temperature fluctuations, noise, vibrations, that's going to affect them negatively. And there's plenty of great studies out there demonstrating the link between stress and poor egg quality in fishes of all kinds. In general, at least when it comes to benthic spawners, I think it's much better to remove eggs from the tank than larvae. A lot of people have something that started spawning in their tank and they can't find where they're spawning. They don't know where the eggs are. They're spawning on the glass or on a rock that they don't want to or can't remove. And so they put a larval catcher on there, which is fine, it'll work. But if you have the opportunity to pull the eggs out and hatch them into the rearing tank, that's better, usually. It's not always better. And the grommas are a good example of a species where that's not better. They keep nests that are constantly going. During their spawning season, from January till May, they lay a few eggs each night and a few hatch each night, and they keep this tank, this nest going all the time. And if you go in there and try and rip out that nest and hatch those eggs, you're going to pull out a lot of eggs that aren't ready to hatch yet. You're going to disrupt the parents, you're going to stress them out, and they're probably not going to spawn for another 2 weeks. So it's really better in this case to let them hatch in the tank, in their little crevice that they've found, and their nest that they've built out of bits of algae or floss or whatever you've provided for them. And in that case, it's really best to use a passive kind of larval trap, which I'll show you in a minute. If you're collecting pelagic eggs, you want to use some kind of mesh. And if you're setting up a tank with breeding in mind, a lot of times people get into breeding after the fact. So their tank's not geared, their system's not planned around spawning and collecting eggs and larvae. But if you're setting up a tank and you're planning to get into this game, then keep in mind the spawning habits of your target species and how you're going to get them out, and incorporate that into the design. In this one, this is where we spawn the flathead perch, the Rainfordia, and well, this was a tank that had an overflow intake and then a lower intake, and I had to glue a piece of plastic over that lower intake because I knew I was going to do all the collecting right at the surface. I didn't want eggs going under that and bypassing my collector here. So I wanted to divert all of the water over the top. I also have most of the flow pumps that are within the tank on a timer that they turn off at night so the eggs or larvae aren't getting battered around after the main recirculating pump goes off. On a night where I'm going to collect eggs, I also dial down the flow of the main pump, the return pump for the system, so that there's not a tremendous volume cascading over that and through the screen. And another really important thing is sample some of the eggs, find out what the egg size is, and use the largest possible mesh size for collecting your eggs. And the reason is you can use a 50 micron mesh here and catch these eggs. The problem is it's going to catch so much more detritus, and it's going to catch just all kinds of gunk, uneaten food and feces and everything are going to stick on it, and those eggs are going to be much more contaminated in the morning when you pull off that screen. So by using the largest mesh size possible, you're going to get the cleanest eggs and allow most of that detritus to flow through. Another hint, when you cut a piece of this material, this nylon mesh, after you cut it, take a soldering iron and singe the edges. Otherwise, it's going to be a big frayed mess after a few days of use. So for pulling larvae out, in the case of the grommas and anything else that's going to hatch in the tank, if you're pulling larvae out instead of eggs, you want to use some kind of a semi-passive trap. So I say semi-passive, there's a light. This is one of Chad Vossen's larval catchers. There's a little light that it's just bright, and it doesn't light up the whole tank. It's just bright enough to be a light attractant for positively phototactic larvae. It attracts them over into the vicinity, and then there's a little airlift that pulls them up and in, and they kind of spin around in this chrysal-shaped trap overnight or until whenever you come in. Usually it takes most of the night to get them. And again, in these tanks, I have the prop units in there are on timers, so they turn off at night, and there's just a very slow turnover of the tank going to minimize the flow pushing larvae around. It allows them to get to that light trap and get drawn into it. It does take a lot of finesse getting the airflow right on these, and what the airflow should be really depends on the larvae. I can't give you a recipe for this. You come in the morning, and if there's no larvae in there, maybe you need to turn the flow up just a little bit. If you come in and there's a bunch of dead larvae in there, probably the flow's too high and they just got beat up in there all night. So sometimes it takes a week or two of adjusting the flow on a larval catcher to get the flow right for the larvae that you're dealing with. Flow, we're going to talk more about flow in a minute, but some larvae really like a lot of flow, and some have no tolerance for it at all. So onto larvae. Obviously, I don't need to tell you this anymore. Copepods are really the bottom line in larval rearing. Not for everything, okay? There's still some fish that need something smaller, that need a ciliate, but for most of what we're working on today, if you're not using copepods in your culture, then I hope you're raising clownfish, because you're not going to have a lot of success with some of these other things. This photo, stolen off the Algagen website. Thank you, Algagen. Don't rush food transitions. You know, whatever you feed, even if I tell you stay away from Artemia or stay away from this or that, you're going to have a progression of foods that your larvae are going to need. And they're going to need something small to start with, and then something a little bigger, and then something a little bigger. And often we have this tendency in aquaculture to speed up the rate of growth. And one way to speed up the rate of growth is to get them onto the next biggest food as soon as possible. But the risk of that is considerable, right? Sometimes it's better to not push that growth rate and let everyone get ready for that next size food. If you push them on to the next size food before they're ready, before some of them are ready, what's going to happen is the ones that are ready are going to take to it first, and they're going to get bigger. And any little size disparity you have in your larvae is going to get bigger and bigger. Whenever you rush the transition onto rotifers or onto Artemia or onto dry foods, you see a big size gap develop between your larvae, and before long they're killing each other or eating each other or outcompeting each other at very least. So whenever you think it might be time to go on to that next food, wait another 3 days. Don't rush it. You'll end up with more uniform size fish, and you'll have better overall survivorship for that. It's very tempting, especially if you have a really high value fish and you have just a few larvae, to get them into a nice big larval culture tank. But it's really hard to manage food density and therefore water quality if you don't have a lot of larvae in there. You can't push much water through a larval tank, and there's not a lot of great ways to filter it, especially when the larvae are small. So if you put in your larvae and then you put in some phytoplankton and some copepods, the copepods are going to reproduce faster than your larvae are going to eat them. Before long, you're going to have too many copepods, and the larvae are going to be getting hit with copepods everywhere they turn. There's going to be, your water quality is going to go downhill faster. So it seems counterintuitive to say it's easier to maintain high water quality with more fish in the tank, but sometimes it actually is if it helps get the food levels back down. Ideally, you want to put food in and have it all eaten within about 3 hours, and then have to add more fresh, new, enriched food. If the food is lingering in there for days and the food concentration is increasing, your water quality is going downhill fast. A couple of words about flow. I mentioned before, and this varies from genus to genus in fishes. I was talking to Noel the other day. He was saying that his anthias larvae really like high flow, especially when they're approaching metamorphosis. I've seen the same thing with dottybacks and with the grammas. Moderate flow in the Liopropoma. Other things like gobies don't like that much flow at any point in their larval development. So you have to know what your larvae like. And I remember, does anyone remember this guy, Joe Lichtenbert, up in Chicago? He was raising clownfish. I've never seen someone raise so many clownfish in such a small space. And I remember I visited his house one time, and I looked in his tanks, and just right at settlement, he had air blasting so hard, I thought, why aren't these larvae dead? And not only could they tolerate this very high airflow, but they seemed to be to me, it didn't make sense how you could have the flow so high, but it changed my thinking about flow in larval tanks. And just because a larval fish lives somewhere where there's a lot of water movement, like say in the Gulf Stream, right off the coast of Cape Hatteras, North Carolina, the Gulf Stream is flowing at a rate of 100 million cubic meters per second, greater than the flow of all the world's rivers combined. There's a lot of water movement there. But just because a larva is found in an area like that doesn't mean it likes a lot of flow, right? Because those larvae, they're all moving as a unit in that water. They don't notice that flow any more than you notice that we're rocketing through space at 60,000 miles an hour around the sun, or that our whole solar system is rocketing around the center of the Milky Way at 500,000 miles an hour right now. It feels like I'm standing still right now. Well, it's the same with larvae. Just because they're in an area with a high current doesn't mean they like high flow. But very often, if you have a larva that's settling on a reef crest or something and you see the way the surge is moving back and forth over that, those kinds of larvae like a lot of flow, especially right at settlement. My best tool for controlling flow, and this is another thing that inspired me. I first conceived this talk actually about 20 years ago. I only wrote down all these things this morning. But I first conceived this about 20 years ago when I was working at Sequest. I noticed the thing that we buy most often at this hatchery is these little wooden clothespins. It's the thing I'm most lost without each day. If I don't have a clothespin to help position something around a tank, or, you know, if you're just trying to keep a few fish alive in a bucket, you throw an air stone in and you forget it. You're just trying to keep them alive. But if you're trying to get the flow right in a tank and your only means to make flow is an air stone, and you know you uncoil that vinyl tubing, and the air stone goes where it wants. It's very hard to get it exactly where you want it and how you want it to get the flow right in the tank. And I found that nothing works like a clothespin for holding a piece of airline exactly how you want it to make the perfect flow. Hands down, it's my favorite underrated tool in raising larvae. Another piece of advice I have to give is try to avoid stocking a tank with mixed species. Sometimes it's irresistible, like when you work at the Long Island Aquarium and you have this big broodstock tank full of all these different species and things are spawning every night, and you throw a plankton net on and catch all of these eggs and put them in it. And so for both Noel and myself, we've had great opportunities to raise industry firsts and just a lot of interesting stuff out of Joe's tank. But one thing that we both have noticed is very often you put a whole bunch of different species together in there and you end up with only one species coming out in the end. One fast-growing, aggressive species like the monos will overtake and eat and outcompete all of the other larvae in the tank. And that's it's true also of if you are in a situation where, like with the grommas, where one spawn isn't enough to fill a larval tank, so you put 2 weeks worth of spawns into one tank so you can have 100 larvae. That's a problem. That size and age disparity is going to cause a huge competition in there. You're going to end up with very low survivorship, at least in a lot of, and in mixed species, you're going to end up usually with high survivorship of 1 or 2 species and almost everything else getting out-competed or eaten. I'm sure, I think both Noel and myself have threatened to quit if Joe wouldn't get this or that species out of the reef. I'm not raising one more fish until you get those monos out. I don't care if it takes a spear gun. And I think Noel made the same threat when it came to the flagtails. Microbes we have to talk about, but I'm not going to say too much because you're not going to find any consensus. You could take every fish culture expert in this room and survey them on how they think you should address the problem of microbial blooms in your larval tank, and I don't think you'll find a consensus. Sometimes it seems like the best thing to do is to start with a sterile tank and sterilized water and everything as clean as possible and just let it bloom up slowly. But then you watch Vibrio tear through your tank or some kind of bacterial bloom and you think, well, maybe it makes sense to add an inoculant of mixed beneficial bacteria, or maybe it makes sense to use a cycled tank that's been running for a while and let a little algae grow. And I still haven't decided what's the best way. This is the kind of thing I'd love to see addressed in some university lab that's really prepared to tackle it. Figuring out, instead of trying to charge forward with how to raise the next new species, I'd like to see some questions answered like, how do we manage the microbial environment in our larval tanks? Because I think it's something we all struggle with, and even often, if you talk to Martin Moe, he and I both came to the same conclusion on a lot of really delicate species. It doesn't matter how you try to cycle the tank. After about 2 or 3 weeks in a tank, sometimes your only way of keeping the larvae alive is to scoop them out and put them into a brand new clean tank because they just can't keep ahead of the microbes. Well, how we dealt with it at Sequest was we used just absolutely irresponsible amounts of antibiotics. And that is not the way to deal with this, I can tell you. Other things to consider, just how to approach some of these problems. I can't address every problem in here. This talk will evolve and I'll come up with more things to, eventually it'll be 700 slides as I think of more of these little hints. But it's important to stop and think about how you're approaching a problem, how you're thinking about it. Often you're trying to solve a problem and you haven't even identified the problem. You haven't stopped to think about what the problem actually is you're trying to, what's the problem? My larvae died. Well, why did they die? I ran out of food. Okay, that seems like a simple answer. You ran out of food, but it's not. So you have to sometimes take a few steps back, ask yourself, all right, well, why did you run out of food? Is it because your food is contaminated? Is it because you're not growing enough phytoplankton for the amount of food that you need? Is it because you tried to raise 500,000 larvae in a system that's only designed for 1,000 larvae? Is it because you haven't allocated the right proportions of space for phytoplankton and zooplankton? Are you just outrunning it? You know, you have to identify that. And so saying that you ran out of food isn't really identifying the problem and allowing you to solve it. So it's really important to step back and work on identifying that problem. We all kind of fancy ourselves scientists here. Some of us, myself included, sometimes we're just pretending to be scientists, right? But often the scientific method doesn't really make sense in what we're trying to do. Sometimes it does, but there's a place for the scientific method, and if you absolutely need to raise this next larva and they're dropping like flies, sometimes you don't have the luxury of saying, all right, well, let's approach this scientifically and isolate each variable one at a time, and will take 10 years. My thesis advisor in graduate school gave me this great advice when I was trying to revolve my thesis around raising a new species, and he said, Todd, you have your whole life to raise new species. Right now, you need to graduate. So don't jump into a project that might take you 10 years because you don't know what you're doing. You have to graduate, take something simple. That's why I ended up doing seahorses, which weren't as simple as we hoped, but I raised a bunch of seahorses. Anyway, it was really good advice, and it's a little bit sad though, because I look at some of the best outfitted research facilities around the country and I watch how many of the research projects coming out are just about producing a better tilapia fillet or solving another problem in shrimp or catfish or, you know, something that we already know how to raise. Everyone has this problem. Students need to graduate and they need to move through. So sometimes when it's really imperative to raise this next larva, you don't have that luxury. Why is it so imperative to raise this larva? Well, maybe your nemesis is working on the same species and you need to beat him to it. Or maybe you're raising larvae for a living and your family's going to starve if you don't keep producing them and you need to keep them alive. So instead of isolating one variable at a time, you just do all the things you can think of at once, the shotgun approach, and try to just keep them alive. And so you end up raising a bunch of fish and you don't really know why you did because you couldn't approach it scientifically. Another piece of advice I have is lose this attitude that one or that certain species are beneath you. Get some experience raising everything. There are great lessons to be learned from raising clownfish or gobies. I've had a lot of people tell me in recent years, grommas, well, grommas they're a piece of cake. And I ask, well, have you ever raised a gromma? Well, no. Or, well, I had some, but the larvae died. I ran out of food, though. That's why they died. So there are a lot of really great lessons to be learned from raising guppies, for that matter. So don't think that a species is beneath you. You can spend your whole life working on raising things that you don't end up raising. There are So many things to be learned from raising clownfish. One of the things I learned, we had a pair of clownfish at the aquarium. It's still there. It's been spawning for 10 years. And we've never raised any offspring from this one pair of clownfish. So sometimes if you're working on an angelfish or a basslet or something a little more difficult, and you're not having success, don't always assume that it's because you're not giving the larvae the right food or that there's something wrong in the larval rearing. Sometimes, and these things spawn and the eggs hatch. Noel can tell you, he's been beating his head against the wall on this same pair of clownfish. John Coppolino gave them to us. Thanks, John. We can't raise those larvae for anything. They spawn all the time. But that's an important lesson. Other things. To keep yourself motivated, set some goals and offer yourself some rewards. My reward when I raise a new species is I get a fancy bottle of gin. And I don't drink it in one sitting, but I drink it pretty quick. That's my reward when I reach a new milestone. Don't underestimate the importance, or don't alienate your non-fishy support system, your friends. And sometimes we get so obsessed in what we're doing that we alienate all of our other friends and family. And there are going to be times when you have some devastating loss in your fish room or your lab or your workplace, and where most of your fishy friends are probably your friends online, right? And you're going to be really down about it. You're going to be crushed. You're going to need to step away. And no amount of teary-eyed little emojis from your Facebook friends are going to make you feel better. And you're going to need those other people in your life to help get you through some of these difficult times. So don't completely alienate them. Don't alienate your fishy support system either. Those people are important too. And of course, as Joe will tell you, break child labor laws whenever possible. Another good piece of advice is sometimes when you've been working on some of these problems for a long time and going in 7 days a week and beating your head against a wall, you need to just step back, take a break, take a few months off of raising fish and clear your mind and approach it fresh. I don't mean a week-long vacation. I mean take a couple of months off and then come back to it. It's one of the most helpful things for me. Every couple of years I do this. I get up and I move and I break down what I'm doing and I start a new lab somewhere else, and it really helps me approach some of these things with a fresh perspective. And while I have this slide open, let me say thank you to my support system, Ashley and Finn, who helped get me through all of this with tremendous understanding. I wanted to finish off with just a little bit of, I know my presentation was kind of short on eye candy, and now my video froze. Oh well. Now the whole thing, now my last slide's probably going to freeze too. Anyway, here's a tank of Grama de Jongai. I think now it's possible there are more captive bred Grama de Jongai in captivity than wild caught ones, maybe just in this one tank. But there they go. So not the most difficult species to raise, but still pretty challenging. It's a delicate larva. And difficult to collect the larvae, but with a little persistence, any grama is a pretty raisable fish. They're about like dotty backs, but with smaller spawn sizes in terms of how they are to raise. Last thing I want to mention, support companies and products, that are important to you. Not only because maybe they give you free stuff or they support your work, but more importantly, really, because if you're counting on them for a product that you use, that you need, and a lot of these companies, there's not too many of them. I look at Algagen and Reed Mariculture. They're the only ones really doing what they're doing. If we lose them, we lose something we need for raising larvae. We need to support all of the companies and products that are important to us, mostly just for fear of losing them. We count on these people and we should support each other.